In example 1, we're going to start talking about translating exponential functions. Your transformations that you have for your vertical transformations, your horizontal, your reflections, they actually work the same for every single function that you can use. So we'll be doing the same ones with our log functions, and when we get to our trig functions, it'll work the same way as well. You might have done them in the past with your quadratic functions. I know in Algebra 1 we did them back with the quadratics. You might have done them again in AAT or Algebra 2. But let's go over it with your exponential functions. So my vertical translations, which are up and down, if I'm adding something to the outside of my function, that tells me I'm going to move it up. And if I subtract something away from my function, it tells me it's going to move down. My horizontal translations, which are left and right, if I look in my exponent, okay, this is adding something within my function. So that's going to move it to the left, and subtracting inside that exponent is going to move it to the right. It's kind of the opposite of what you want to think it to be. But inside, the plus is left and the negative is right. Reflections, if you have a negative on the outside of your function, that's going to reflect over the x-axis. And a negative in the exponent, that's going to reflect over the y-axis. And then vertical stretching or shrinking. If you have a number that you're multiplying in front of your base, that's going to stretch your graph vertically. And then if that number is greater than 1, and if that number is between 0 and 1, it's going to shrink your graph. And then horizontal stretching and shrinking, that's going to come with a number that's being multiplied by your x up in your exponent. So if that number is greater than 1, it's going to shrink the graph. And if that number is between 0 and 1, it's going to stretch your graph. So we're going to use these down below. So let's take a look at letter A. We have our function here, which is y equals 1/4 to the x. And we want to translate it to become the graph of y equals 1/4 to the x plus 1 plus 3. So the first thing we want to think about are what's our transformation. So the transformation within the exponent here, this plus 1 tells me that I'm going to the left by 1. And the plus 3 here on the outside of my function tells me that I'm going up 3. Now the first thing you have to remember here is that we do have an asymptote in our original, and our asymptote originally is here at y equals 0. And I would always suggest that you move your asymptote first. So if I think about this line, if I go left, that line's not going to change. It's going to stay in the same spot. But if I start moving my function up 3, that asymptote will also move up 3. So the first thing I'm going to do is represent that asymptote, which is now here. Then I can take a couple points off my graph and move those. So the first one that I have is the point 0, 1. And I need to move that point to the left 1 and then up 3. So that's now going to be at the point -1, 4. So I'm going to plot that point there. And then if I take another point that's on my graph, something else, it looks like I have also the point originally at -1, 4. And if I move that to the left 1 and up 3, I get the point -2, 7. So I know I also have the point -2, 7. And then I can sketch what my graph looks like. So my graph's coming here, and it's going to follow along that asymptote. We can also do it if we look at letter B. We have the function y equals e to the x. We're going to talk a little bit more about the letter e tomorrow in the notes, but know that e is just a number. It's an approximation, kind of like pi. And again, we'll talk a little bit more about e tomorrow. But if we have our graph y equals e to the x, and we want to do e to the -x minus 5, we want to figure out how this graph is moving. So if you don't remember that negative up there in the exponent, if we go back and look at our table, the negative up in our exponent tells us that we were reflecting about the y-axis. So that means this graph that we have here is going to reflect over the y-axis and kind of come this way. And then we're also moving it down 5. So let's once again think about that asymptote that we have here. And the first thing, if we reflect that asymptote, that means this part of my graph reflects over to here, and then this part of my graph reflects over here. So that reflection does not change the asymptote, but moving it down 5 will. So let's go ahead and move that down 5. So we know that our new asymptote is right here. And then let's think about a couple points that we have on our graph. So if we look at this point right here, this point is on the line of reflection. So if we reflect it over, it's not going to go anywhere. So it's not going to reflect since it's there, and then we need to move it down 5. So if we move this down 5, we get 1, 2, 3, 4, 5, and it's now at the point 0, -4. So let's plot that point. And then let's find one other point on our graph. So if we take a look here at the point 1, 3, if we're reflected over the y-axis, it goes the same distance away but over here. So it becomes the point negative 1, 3. And then I move it down 5. 1, 2, 3, 4, and 5. So I get the point negative 1, negative 2. And then I can draw in my graph, which is going to look like this. If you have any questions on translations, please let me know.